All right, guys, welcome back, and thank you to Impervious again for sponsoring HandyCon. Right now, we got David Vork. Everyone, I would hope most people in our community know his name, CEO of Skynet Labs. We are like buddy, handshake and Skynet. So we're really glad and really happy that we could take some of his time so he could speak here at HandyCon. Mike, you want to say anything else?
Yeah, sure, David. You can load your slides now if you want. I mean, if it takes a second, but yeah, I mean, we're all very appreciative. It's like yeah, like you said, brother sister, between Saya and Handshake, and I know you've been going through a lot. I follow your Twitter, with the fighting the old internet, Web 2. I've seen you're on mute now, David. So I don't know if you're speaking.
Hey.
Oh, there you go.
How are you doing?
Yeah, so we've been seeing your struggles, with the, so we support you here, and if there's things we can do, more to help you guys, it's great to see you're on the front line. Seriously, it's amazing.
Well, thank you, and yeah, it's great to be part of the Handshake community. I love everything you guys are doing, and I think Web3 is challenging, and not everyone who uses the Web3 name is committed to the values of the Web3, movement. But I think Handshake is, right there alongside Skynet in pursuing the best. So yeah, I'm super happy to be part of this community. I'm glad Handshake exists.
All right, awesome. Yep. Well, we won't eat up any more of your time. You can go ahead and take away take it away with your presentation.
Awesome. So thank you everyone for coming. I wanted to talk today about the Skynet Kernel, which is a new web browser extension we've been working on for Web3. And so I'm just going to dive right in. I guess, yeah, background. I'm David Vork, founder of the Sia blockchain and founder of Skynet and Skynet Labs. So yeah, you guys already know. So Web3 has a trust problem. Moxie Marlinspike, the founder of Signal, wrote a big article recently that gained a lot of visibility about Web3 and how basically a lot of the just ways you interact with Web3 are reminiscent of Web 2. It's a very trusty ecosystem, and it feels like a lot of smoke and mirrors, and like a lot of the promises of Web3 aren't being delivered on. And so I think he really, keyed in on two critical things, which is that when a user joins Web3, they load their crypto app through a centralized front end in the web browser. And so even if you have a browser extension like MetaMask that protects the user's seed, it doesn't protect the front end itself. And then the second thing is that the front end queries a centralized API such as Infura and fully trusts all the responses. So even if your centralized front end ends up being honest, usually that centralized front end is dependent on a centralized API like Infura that, once again, can be used to manipulate the user, lie to the user, or drain their funds. So we focused in on the Skynet kernel on these two key issues. We want to kind of solve the front end problem, and then just as important, we also want to solve the API problem. So yeah, I'm happy to present what we've come up with. We've built a browser extension that combines Skynet, which is a decentralized storage platform, with a web browser API called onBeforeRequest. And basically what this allows us to do is it allows us to catch the web request to any DeFi or Web3 front end, any web app that's supposed to be Web3, we can catch that web request and we can get in the middle and we can verify that the code being served by the server is the code that the user is supposed to load. So we can take these centralized front ends and we can turn them into decentralized user-controlled front end. So I believe the next slide is a diagram. Yeah, so you can see when you install the Skynet server, the Skynet kernel, basically instead of the user sending a request to a centralized server and then getting a centralized response back, the Skynet kernel catches that request, talks to Skynet, checks the user's verified storage, and then either verifies the request or can even inject a different response and make sure that the user is getting the code they want. So the Skynet verified storage is, for those unfamiliar with Skynet, it's a decentralized storage platform where all of the data that you are looking at as a user is signed by your own public key. So when your browser extension, when the Skynet kernel is checking your verified storage to make sure that the right application is being loaded, it's not trusting any Skynet portal. It's actually doing signature verification and hash verification, and it's making sure that the Skynet APIs it's talking to are also being honest. So when you add the browser extension, you get this full end-to-end trustless experience that allows you to deliver decentralized applications straight to your web browser, and you don't need to install a separate application or run a background service. You just have a web browser extension. So that's something that we're very excited to have built out, and we're excited that it works. So I kind of alluded to this briefly earlier, but one thing that you can do as a user is you can configure your kernel to replace the front ends with different front ends. So if you want to fork, or if you want to go to a previous version, you can configure your kernel to intercept, say, like app.uniswap.org, and replace whatever you think should be responded by the server. The browser extension has full control over it, and of course, the browser extension hands that control over to the user. So you get this very clean user-controlled experience, and that's really what Web3 is about. We want to make sure that the user gets to decide what their experience is like. So that solves one half of the equation. We have the front end solved, and we can load that, but we still have a front end that's talking to these centralized APIs and often using services like Infura. So we developed a system called Kernel Modules that allows you to take these centralized APIs and turn them once again into client-side trustworthy code that's verified from the user. So essentially, a kernel module is a piece of code, generally JavaScript code, but it can be WebAssembly or basically anything you can run in a browser web worker. It loads it, and then it serves the module serves an API that web apps can use, and that other modules can use. So a key thing about modules is that they can be swapped out just like the front ends. Modules are APIs, not libraries. And so if you have a web app that's talking to, say, an HNS module that serves an API that resolves domain names, and the user, decides they don't want to be SPV, they want their module to be using a full node, they can go in and swap that module out in their kernel. And because it's an API, when they make that switch, all of the applications that they use, which talk to that handshake API, now switch together over from SPV to the full node. And so again, this is the reason we've broken everything into modules, is to make sure that the user has maximum control over the behavior of their applications. And so, yeah, I think that this is a significant advantage over libraries because it allows the user to control all of their applications at once, rather than having to update one application at a time to change out the APIs that the application uses or the libraries that the application uses. So one of the fun things that you can do with the kernel is, just like we can intercept requests to app.uniswap.org, these kernel modules can also intercept requests to centralized API services. So if you are using an app that's been hard-coded to use Infura, you can program the kernel to actually intercept the API requests that are going to Infura, replace them with a call to an Ethereum module or whatever whatever API that you want to replace them with, and then have the kernel respond with trustless API responses. So even if you're using a application that is hard coded to use centralized endpoints, the Skynet kernel can get in the middle of that application and upgrade that application to being decentralized for the user. So finally, one more thing you can do with kernel modules is use them as first-class programs. They essentially run as background processes in your browser. And so they are fully sandboxed programs that have long lifetimes. They have full access to each other's APIs. So you can build like a kernel module that's talking to the Skynet APIs, talking to the handshake APIs, talking to Ethereum APIs. And you can build something like a full node that runs as a kernel module. So you can have blockchain full nodes in your browser that are fully trustless, that serve APIs that other applications can use. And something that we were very careful with is sandboxing. When the user installs a kernel, that kernel goes into its own private sandbox where it has its own storage and it has its own seed that's derived from the user seed, which means because it has a seed, it can do basically any crypto operation it wants. But it's a unique seed that no other module knows. Obviously the user knows it, but no other module knows, and it's got private memory and private storage. So if the user accidentally installs a malicious module, that actually doesn't do any harm to the user. The malicious module is in its own sandbox. It can hurt itself only and doesn't interfere with, say your blockchain module that powers your HNS wallet. So this is something, I've been very excited about over the past 6 months. It's amazing to be able to finally talk about it. And of course, this is a handshake talk. This is a handshake conference. So we got to talk about where handshake fits in. One of the things that we figured out with the Skynet kernel is that we can do custom TLDs. So you can go to, say, like the kernel itself gets hosted at Skynet kernel.skynet. So we kind of hard coded the Skynet TLD, but you can introduce modules like, say, a handshake module that will allow the kernel to resolve any TLD supported by handshake. And so one of the things on our early roadmap for sure is to get full HNS support in our browser through the Skynet kernel. And for people who don't know, the Skynet community are big fans of handshake. Most prominent Skynet apps have a handshake URL in some form. And so, it's high priority for us to get first-class handshake support into the Skynet kernel. Cool. So Web3 has a trust problem, but the issues are not fundamental and the issues are not unsolvable. We have built the Skynet problem to basically tackle the core of everything Moxie was concerned about, and Web3 can continue building the way it has been. We do have a trustless future, on a roadmap, and it's not like a throw on the brakes and turn around and we got to start over. We can take all of the existing applications and we can take those centralized APIs and we can inject trustless responses. We can intercept them and we can build back to trustlessness without having to throw away all the work we've already done. I hope you found the talk interesting. If you want to learn more, you can join us at discord.gg/Skynet Labs. I believe I'll go back one more slide. We have a GitHub, so the kernel code has been open sourced. I think we released it about a week ago. And we would love to have you guys contribute. But that's about all I had to say. We can open the floor for questions.
All right, awesome. I saw Matt Zipkin getting really excited in the chat, and I said, when he's getting excited, it's something good. So definitely cool to see. And he did have one question here, but it may have already been answered.
So the centralized servers do not need domain names. We have basically, so as an example, the kernel itself, the browser believes that the kernel is hosted at kernel.skynet, which of course is not a URL that actually exists. So we have basically a proxy system with failovers. If you are releasing a website, you don't need any existing ties to the DNS system to be able to host something through the Skynet kernel and have a URL that users are going to be able to use to view your application.
All right, cool. So I'm seeing in the chat that there's not like a ton of very super duper techie people, so maybe they're not the best people to be asking the right questions, and me too, I guess, really. But maybe you wanted to talk about like home screen really quick. Oh wait, here's another question in the chat really quick.
Yeah, so right now the kernel is only working on Firefox. So if you're a developer, you can come in, you can help us port it to Chrome. Another thing that would be just a huge help for the ecosystem is that we don't have very many modules at this point. Like the kernel was just released. So if there are APIs that you know how to decentralize, and whether it's something as big as like Ethereum APIs or something as small as just like a single query to check the height of a blockchain, come build a module, come start to build that ecosystem of APIs that other developers can use to get trustless access to Web3. And then of course just spread the word and be a user.
All right, awesome. I'm looking in the chat for any other questions.
Yeah, I see a question by Blake, which is, will the domain actually resolve and stay in the browser versus using a forward? And the answer is yes, it will resolve and stay in the browser. So your URL bar will say, either whatever.hns, or if you've configured HNS to have like the full suite of TLDs, you'll just see the TLD in your browser URL bar. And there's one caveat there. The browser will say that it's HTTP, and that's because it doesn't recognize the SSL certificates for domains that don't exist. Understandably, it's hard to get those certificates. So we have to say that it's HTTP, but on the back end, it is secure. It is doing encrypted communication to whatever portal it's using, and like it is doing client-side verification. So even though it says HTTP, it's a side effect of just how the browsers were built. It is a secured connection, and you can rely on it.
And then it looks like he's asking about collisions as well. I don't know if this is in regards to TLDs, like ICANN and the HNS namespace colliding, or something different.
Yeah, I mean, I can talk to that. And the answer is that if there is a collision between ICANN and HNS, basically the module will have to decide how to handle that. And so you could have like a very heavy-handed approach where the HNS always wins, and that's something you could configure in your kernel. Or you could install a module that like is the other way and ICANN always wins, or you could have it like the user set it on a per domain basis, and just like even if it recognizes a certain SLD, it'll switch which TLD it goes to based on what it knows. But the point is that that's entirely up to the developer writing the module, and the user can switch between modules if they decide they want things one way or another. So yeah, we don't have any like central control over how collisions are handled.
Well, that's awesome, because in the community, that's what we talk about all the time with name collisions. We always leave it up to the resolver to kind of handle that. So that's perfect. Awesome. Thank you. And then here's a question from Johnny Wu.
What is the main takeaway benefit of Skynet kernel in relation to Handshake? Yeah, so right now, when you go to, so one benefit is that you'll be able to go to handshake TLDs in your browser. And I know there are other extensions that do this, but this is just another way to do that. But another benefit is that when you resolve those links, I think most other extensions use some sort of centralized resolver, or they expect you to run a program locally on your machine. So with the Skynet kernel, you can basically install the extension into your browser, and then that's the only step you have to take. The kernel can then load trustless modules to get you initially. So in the beginning, we'll probably be doing SPV modules to load or to resolve handshake names. But with the help of U3XO, it is completely technically feasible to run an entire HNS full node from your browser, and that may require some a little bit of rewriting just to meet the storage limitations of the browser. But we do know that it's possible to build a blockchain full node that runs as a kernel module, and we are building our own blockchain, the Skynet blockchain, as a kernel module.
Well, I think everybody's really excited about that. That's pretty fucking awesome right there. That's really cool.
Thank you.
And then another question from Johnny Woo.
What's your largest roadblock right now? Yeah, so I mean, really, it's just time and getting people to build more modules. I think this, kind of like the node ecosystem. The node ecosystem is a lot more interesting when there are a lot more node packages. The Skynet kernel ecosystem is a lot more interesting when there are a bunch of kernel modules. And so you can build handshake modules, you can build other blockchain modules, you can build, social graph modules. The modules don't have to be strictly talking to a blockchain. You could have a module that just knows the list of who your favorite friends are. And so building that sort of stuff out is going to help things. But yeah, we hope to have significantly more ready in about a month. And then we had a comment from Matthew Zipkin about how it's slow. So yes, the main approach to doing full nodes in the browser is using WASM to validate blocks. And then we use a technique called U3XO to eliminate the need for a database. So you basically have the state of the blockchain represented as a Merkle tree, and a transaction, rather than being standalone, includes a Merkle proof for which state it's touching and how that state gets updated. And so it allows full nodes to skip out on having any sort of database, and then to do all the hashing and signatures and the computationally expensive stuff. Basically, the whole block gets verified inside of WASM. And then something that completely blew our socks off when we were benchmarking, we found that doing crypto operations in Rust WASM had less than 10% overhead of doing crypto operations in Rust bare metal. So if you're using Rust WASM, it's essentially as fast as doing Rust bare metal. We were completely blown away. This was not the case in 2020, but there have been 2 years of developments and optimizations, and I think a lot of people committed to making Rust WASM fast, and they have done a good job. They have impressed us immensely. So yeah, we highly recommend Rust WASM if you need a module that goes fast.
All right, cool. Definitely people getting really excited. And then this goes back with the HTTP. Dope Man is just asking, like, going forward, will you make it clear that the connection is actually secure? So for the end user, that's clear to them.
Yeah, so the best we can do right now is messaging. The ideal scenario is that we can work out some deal with the browser itself. Like we can talk to Firefox and Mozilla. And I don't think we'd have much success with Chrome, but maybe with like Brave or Opera, so that they make an exception and they know that if it's a kernel loaded URL, they just go ahead and display the secure lock anyway and let it be HTTPS. But I don't know like how long the road to that conversation is. It's obviously a very political thing as opposed to a technical thing. So we will, the goal or the way to fix that would be to get the actual browser vendors to sign off on presenting the secure lock for all of the kernel loaded web pages.
Yeah, browsers have been the main gatekeepers with all this stuff. That has been definitely a common thread. Here's another question from AMD.
Yeah, so is it possible that Skynet makes a Web3 browser application like the others? So Skynet, as in Skynet Labs, will probably not make something like to replace Google search, but kind of the goal and what we're trying to build is we're trying to give everyone else the tools that they need to build their own applications. And so if you personally feel like, Google search is something that needs to be replaced, come join our community. We'd love to spitball with you and come up with ideas and figure out, what it takes to make the decentralized Google search. The goal here is to replace Web 2 with a decentralized Web 3.
All right, cool, awesome. And then this will be probably our last question here.
Yeah, so minimal hardware requirements. We don't know yet. For the bare bones Skynet kernel, basically anything that can run Chrome, which itself is kind of power hungry. But if you can run Chrome, you can add the Skynet kernel as well. For the full nodes, we think that we can get the RAM requirements of the full node under 50 megabytes. So we think that it can be pretty lightweight, but we're not going to know until we finish writing the code. So we have ideas, and we will see if they work.
All right, cool. And actually, maybe one more from Steven.
I have not had a chance to look into HNS search, so that will go to the top of my list. And I'm excited to check it out.
All right, cool. He's actually speaking later today as well, so if you want to check him out, he's speaking in a couple of hours.
Awesome.
All right, so we're almost at time here. You got everybody very, very excited. You got me very excited. So we're very much looking forward to where this heads in the future. You got us very inspired, David. So thank you again for giving us your time. Any last words?
No, it's great to be here. I'm glad everyone's excited, and I'm glad that you guys are excited as I am. I think it's incredible, and it's good. It's good to have company.
All right, awesome. All right, we're gonna end it here. We're gonna be talking next with Alani from Akash. So I hope to see you guys there in just a little bit.
Kinetic is a blockchain crypto investment firm based in Hong Kong and Puerto Rico. Founded in 2016, they were the first fund in Hong Kong and one of the earliest in Asia. With a portfolio of over 220 companies, they were seed investors in such projects as Ethereum, Parity and Polkadot, Solana, FTX and of course Handshake and Namebase. Founder Johan Chu is an active investor and supporter of the Handshake ecosystem. Over 100,000 domains, co-founder of DWeb Foundation, co-founder of HandyCon, and sponsor of the Handshake House at Miami Hack Week 2022.